Hello and welcome back to the Lean Programmer, and this is your friend Madhav. And today we have another video on low level system design. Today we are going to study about strategy design pattern, which is one of my favorite design patterns. But before we go ahead, you have to hit the like button and hit the subscribe button if you want to see more of my videos. And if you don't know, I am creating 100% free course on low level system design, which can take you from zero to ninja level to Naruto level in system design. All you need to do is go to my YouTube channel, youtube.com/slash the lean programmer. Go to the playlist, and in the playlist you'll find the system design course, which will every video in this course will have live coding examples. It will tell you what design pattern to use, when, what are the benefits, and every video will be having hands-on coding. So you're going to enjoy it a lot, and you're going to enjoy today's video a lot as well. So I want you to tighten your seat belts and we can get started now. So before we go ahead, before I tell you what is strategy design pattern, I want you to imagine a scenario. Just imagine a scenario that there's a 6-year-old kid who wants to go to school from home, who wants to go from home to school. And there are multiple ways of doing that. There are multiple routes from school to home. One of them is the shortest, one of them is the fastest, and one of them is the prettiest. So it depends on the mood of the child on which route he wants to take. Someday, when he's running late, he might want to take the fastest. One day, when probably the maybe his parents are running out of petrol or gas in the car, they might want to take the shortest route. And someday, when they have a lot of leisure time, then they might want to take the prettiest one. So each route gets you to the same destination, but the journey is different. So the strategy of going from one place to another depends, right? Just remember strategy because we're going to come back to this. Now, just imagine if the kid is going alone, the kid needs some instructions. He does not remember all the paths yet, he does not remember all the routes yet. So his mom takes on the task to explain him the routes. So what she does is she takes on a pen and paper and starts writing all the routes in a big if-else condition. Now just keep imagining the code for this in your mind. So we have to make a app which tells the user the routes between the paths between place A to place B. One way to implement that is if else condition, if else ladder. If you want to take the fastest route, do this. If you want to take the scenic route, do this, and so on. But this will just create a very huge list of instructions. It will become very difficult for the kid to read and the mom to write as well. And what if there are many routes? What if there are many use cases? If it's going to just become a very huge if else ladder. It will be very, very difficult to read. It will be very difficult to write. Now, here's where strategy pattern comes into the picture. This is exactly where strategy pattern helps. Now, just imagine instead of doing manually writing the instructions, now what the kid does is kid says, "Hey mom, I'm of the 21st century kid, and I don't need instructions on a pen and paper. I have this app. This app knows that I need to go from A to B, but this app allows me various options whether I want to take the fastest, shortest, or the most scenic route." Just remember this, okay? So the app knows various strategies. The app knows when to plug in which strategy. I want to take the fastest route. I want to take the shortest route, and so on. So it's like a strategy. It's not going to be a very huge if else if ladder now. So you just need to, for now, I'll tell you how do we do that in code. But for now, we just need to remember that the app does not change. We just swap our strategy. You won't understand the importance of the design pattern unless and until you try to build something without it. So we are going to build the whole navigation app without this strategy design pattern. So it's going to be simple. We don't need any huge logic. What we need to do is a single giant class which is trying to handle all the navigation routes. So let's take a look at the bad code. And all I want you to do is inside your VS Code, just create a bad code.java. Same thing, same examples. I always write bad code and good code to explain you, and we'll come to why is it bad code later on. So we'll just create a new main file, and we're going to say we have to create a new route planner here. Okay, so let's create another class called route planner. All right. And this route planner is going to basically have a public function which is going to create or display route. Okay. It's going to take a string from, it's going to take a string to, it's going to take a string type. Simple. And then it's going to have a big if else ladder. If type dot equals ignore case fastest, then we are going to basically first we are going to print calculating the fastest route, and then we'll just say expressway. All right, and then else again I'm going to just copy and paste this. I'm telling you why it's so bad because you see yourself copying and pasting a lot of code as well. Shortest route, calculating the shortest route, and let's call it highway is the shortest. And then again, else if type dot equals ignore case, scenic. In case of scenic, we are going to again print calculating the scenic route. All right. And then we are going to say the scenic route is garden. I don't know which school is made on top of garden, but anyways. And finally, we can just print out some sort of an error saying that couldn't find blah blah blah. All right. So you can already imagine how difficult it's going to be. So because for now you just see the print statements, but it could be a huge logic here to find the actual route. Now just imagine a single file having all this logic, all this logic again and again. It's going to be so bad. But all right, let's for now let's just try to complete this. So we are going to first let's create a new route planner equal to new no route planner, and then let's just say planner dot display route. It's going to be from home to school and fastest. Let's try to run it. Obviously it works. It definitely works. It will work. Yeah, calculating the fastest route, expressway. And if you want the shortest way, we can just replace it with the shortest. And this will definitely work. No problem at all. But then there are lots of problems here. Why? Let's take a quick look at this. First of all, just imagine these you are actually working on this app and these are not just print statement, these are actual 1,000 lines of code in every conditional. It's going to make future changes very difficult and error prone, and it's going to be very frustrating for the developer who is actually maintaining it. So, first of all, you are trying to add a lot of responsibilities in this single class. This single class is responsible for finding the route, finding the type of strategy, fastest, smallest, whatever as well. It's also responsible for printing. It's responsible for every single thing. You are adding every single thing of this app, every single feature of this app in a single class, which means you're breaking the SRP, single responsibility principle. What is SRP? What is single responsibility principle? If you want to learn this, type SRP in the comments and I will make a video on SRP or solid principles. It violates open close principle, OCP, another solid principle. So what does OCP say? Our class should be, or our function, or basically our app should be open for extension but closed for modification, which basically means we should not be modifying this again and again if you have to add a new type of strategy or a new type of route. But we will have to, let's say if We have another requirement in future to add the type dot equals ignores case, let's say cheapest. You'll have to modify the whole code, and that completely breaks the OCP. What is OCP? Again, if you want a video on this, just type OCP in the comments and I will make another video. So it's harder to test and reuse. There's a lot of confusion. There will be a lot of errors, and the managing this class and testing this is going to be very, very difficult. So what's the solution? Solution is, as we are discussing today, strategy pattern. Strategy pattern, what exactly is this? Strategy pattern is basically, you can imagine it as a backpack filled with different tools. Sometimes you might need scissors. Sometimes you might need marker. Sometimes you might need a glue stick, right? You have various tools, but depending on what you need, depending on the context, let's say you want to cut the paper, you need scissors. You don't need glue stick to cut, right? So let's see how strategy pattern works. So strategy pattern, what is strategy pattern? Basically, it defines family. Basically, you can encapsulate a lot of algorithms and make them interchangeable. The context object uses a strategy object. How does it work in code? Don't worry, I'll explain you. It will be very clear when I explain you the code. So don't worry about it. You just have to remember that the algorithm can be changed at runtime, which basically means just remember our navigation app, right? In our navigation app, in the runtime you can decide which strategy to choose. Okay, how do we implement this? It's very simple. There are going to be four different things that you need to do. First of all, we have our strategy. Just remember this. A strategy basically is going to be our abstract class or our interface, which is going to define the functions or the things that there should be. So in this case, our interface should probably have display display route function. Okay, this is going to be our strategy. Then are going to be concrete strategies, right? The one of the concrete strategies could be fastest. Basically, there will be multiple classes, strategy classes, which are going to implement this, right? One of them could be fastest, one of them could be shortest, one of them could be scenic, and so on. Now you're trying to understand, right? Now I think you're getting it. You're getting it, right? This is not an if-else statement. Our strategy itself is a new class. There's going to be a new class, fastest, which basically removes our if-else statement completely. Okay, so there's going to be the fastest route strategy, there's going to be a shortest route strategy, there's going to be a scenic route strategy. So each class will implement its own strategy. Then there's going to be a context. So our context could be the navigation, right? Let me just undo it. So our context could be the navigation class, which basically decides which strategy to use in the runtime. All right, and then finally there's our client code. Our client code it can interact with the users. It can decide. It can give the users the option to decide the strategy. So how does it look like in the code? In the code, we are going to first of all have our context. This is going to be, in our case, this is going to be the navigator app navigation. All right, this navigation is going to hold an instance of the concrete strategy. It could be any of these strategies. And it can also allow our client to set the strategy, right? Let's imagine we have a app where we can choose the fastest strategy. We have a button for fastest, we have the button for shortest. If the user clicks on the shortest, we'll set the strategy to the shortest one. If the user clicks on the fastest, we'll set it the fastest. And then basically it depends on the strategy. And then in the runtime, based on whichever decision, whichever strategy is chosen by the user, it could create an instance. It could set the instance as a fastest one, a shortest one, or the most scenic one. I hope you're understanding now. Let's see this in code. It's going to be amazing. It's going to be wonderful, and you'll love this design pattern. I'm pretty sure you'll love this. So let's quickly do our good code.java. We're going to create a new class, good code. All right. In our good code, basically, we are going to first of all have a main where we are going to again create a route planner, or we are going to basically create a navigation. In this case, we are calling it navigation system. All right. So let's go step by step. So the very first step is we have our own strategy, right? We have an interface strategy, which let's say interface strategy. This strategy is going to basically have this is an abstract strategy. This is not a concrete strategy. This is just going to enforce, even if we add a new strategy, this is going to enforce that any kind of strategy that you add, you should add a display route in that strategy, or we can call it build route, whatever, or you can call it create route, whatever. Let's call it build route for now. All right, this build route should have a string to, and it should have a string from. As simple as that. So as long as you have a, a starting point and an ending point, we will be able to build the route. Now this decouples the type of strategy from the client, right? We don't have to keep on manually updating the if-else structure. So let's call it the abstract strategy. All right, strategies, whatever. Okay, so we are going to implement the class fastest route, let's say fastest route strategy, implements strategy. And for any class to implement another interface, it needs to implement the all the functions which are present here, right? So we are going to create void build route. It should take a string to, it should take a string from, and so on. The same thing. Let's just copy and paste this from here. All right. We'll just tag it with override. Simple. Now let's copy and paste another two things. Fastest, shortest. We're going to say shortest route strategy. It's going to be highway, if I remember correctly. And then there's going to be a scenic. Calculating the scenic route. It's going to be through garden. I don't know which school is built in the garden, but all right. Now we are done with concrete strategies, we are done with the abstract strategy. Now we are going to build the navigation or the navigator, whatever, navigation. Let's call it navigation. I'm going to call it class navigation system. So our navigation system is first of all going to hold an instance of route strategy. Route strategy. Wait, are we calling it just a strategy? I think we should call it route strategy, right? Because yeah, this feels better. Route strategy, route strategy, route strategy, and route strategy. Let's call it strategy. All right. So we are going to basically create navigator, navigation system with, now we can just say the strategy, this dot strategy equal to new fastest strategy. Or if the requirement is that we need to give it to the client to decide which is the default, then let's just leave it to the current client. All right, so we'll just create a new route strategy. This dot strategy equal to strategy. Simple. Too many strategies. All right, now if you remember, what is this? Set strategy. First thing, let's just implement. So we can give public, basically a setter method. Set strategy. Set strategy. Set strategy. Route strategy. Okay, perfect. Now one final thing that is pending. What? Execute strategy. How will our navigation app execute this? So there's this client, so there's this front end. When we click on the shortest route strategy, we need to do two things. First of all, we need to set the new strategy to the shortest, and then we need to execute it as well. Execute it as well, right? So we'll just say public void execute strategy, or we can say navigate in this case, public void navigate. In our navigate, basically we need again two things, from string to. So very simple. What are we going to do? Here we are going to execute the strategy. How do we execute the strategy? Basically, we build the route. So what we are going to do is this dot strategy dot build route to and from. That's it. As simple as that. Is and we are done. We are done with the highly scalable, highly extensible app. We don't need to depend on any any kind of if else statement here. And this can decide in runtime. Basically, we can decide what type of strategy is on runtime. Basically, the user can click on fastest or shortest and then it will execute. It's basically polymorphism, if you understand it. So now let's say first the default strategy is fastest. So what we need to do is we need to create a new navigation system. We are going to create a new route strategy, and inside our new route strategy, no, not route strategy. We are going to create a new fastest route strategy. That's it. Navigation system, navigation app. Okay. So we are going to say navigation app dot navigate from home to school. As simple as that. All right. Now let's try to run it. Calculating the fastest route, it's going to be expressway. Now, if you want to change the strategy, now let's say the user clicks on shortest. What we're going to do is we're going to say navigation app dot set strategy. We're going to set a new strategy to shortest route strategy. As simple as that. And then we're going to again do the same thing. We're going to call navigate. This is as simple as that. We're just going to, let's say, run the code. It calculated the shortest route, which is highway. So I hope you understood this. Try to take a look at this code once again. First of all, we have an interface or an abstract class, which is going to just define what all should be absolutely implemented. What is the strategy? Our strategy is basically our route type, which is building the route type. Then we are going to implement the concrete strategy, which is going to implement the route strategy. Which can either be fastest, which can either be shortest, or which can either be scenic. And then we are going to build our own context management system in this case, which is the so this context management system is going to hold the kind of strategy which is present right now. So this is going to be the navigation strategy. We are calling it the navigation system, which will basically have a set strategy and navigate, which will basically have a set strategy and execute strategy. That's it. And then our client code will basically just create a new instance of the context management system, which is going to be our navigation system in this case, and we are just going to navigate. I hope this was not too difficult. This is how it looks like. Our navigator or our navigation system has the set strategy and navigate. It holds the current active strategy, which is going to be instance of route strategy or an implementation of route strategy, which could be either the shortest route or the fastest route or the scenic route and so on. All right. So you're done with the code. I hope this was not too difficult to understand. If you had any problems in understanding this, just let me know. I would be more than happy to help you out. Just let me know in the comments. Now, one important question that comes in. Hey, Madhav, in the last video, you discussed template pattern, and today you're discussing strategy pattern. When should we use which one? So if you remember the template pattern, what was the template pattern? Just go to my YouTube video again, once again. Just go here and just see the template pattern. What was template pattern? Basically, when you are stuck in a situation where the first n number of steps to do something is the same, the last n number of steps to do something is the same, but in between, the logic is different. The strategy pattern, however, you want to decide the whole strategy itself is different. In that case, what would you use? The whole way of doing things is different. In that case, what would you use? Strategy pattern. Basically, when you have one task that can be done in many ways, for example, many algorithms, for example, you can have a sort algorithm, and one of them could be merge sort, one of them could be some other sort, one of them could be some other sort, and so on. You have different ways to do something. For example, calculating discounts, shipping costs, sorting, compression, etc. You would probably be, you're very good. It is a very good condition to use strategy pattern. Another condition could be when you want to change the behavior at runtime easily. For example, in the app that we built just now, if the user select fastest, you want to change it in the runtime. One more situation where you probably can think of using strategy pattern is if you see a large if-else statement or a switch case statement in your code, which chooses the behavior based on a type or a string, you probably should consider using strategy pattern. Benefits of strategy pattern we already discussed. It removes big if-else progs. It follows open closed principle OCP. If you don't know what is OCP, just write it down in the comments and I will create a new video for you. Let's say if I want to add a new cheapest strategy, we don't have to change this. We don't have to change this. We don't have to change anything. Our code is open for extension but closed for modification. We are not modifying anything. Everything is immutable. We're just going to create a new what? Cheapest route strategy. Implements route strategy. So you see, just by this much, you have integrated a whole new feature here. However, in this case, you had to change some existing code which could lead to problems. A lot of problems. If you are a software engineer, you know what kind of problems. In this case, a lot of things can go wrong. The developer who will be maintaining this code, they'll be completely confused. Oh my God, such a huge if else. So yeah, it adds more cleaner code, more focused classes, easy to change behavior at runtime, improved testability, and better separation of concerns. So that's it for today's video. I hope you enjoyed it. Don't forget to go to my YouTube channel, youtube.com/the lean programmer, and hit the subscribe button. I will see you in the next video next week. Bye bye.